Hello students, we are in 17th exercise problem of chapter 10, Wave Optics. In several questions we are given. Very first of these questions is, in a single slit diffraction experiment, the width of the slit is made double the original width to the original width. How does this affect the size and intensity of central diffraction band? So we know that the bending theta is directly proportional to lambda by d, where d is width. So if you make this width double, obviously this bending will be reduced, and hence the fringes will be confined to less distance, they will be crowded more. Moreover, intensity is proportional to square of width. So if you double the width, intensity will become 4 times. Moving to second question, in what way is diffraction from each slit related to interference pattern in double slit experiment? So if we consider a single slit, we know that in case of single slit, the diffraction pattern looks like this. Now, when you take double slit, you are actually getting two such patterns, and because of two such patterns, the interference fringes become like this. So you can say that the double slit is combined effect of two single slit. Next one, C. When a tiny circular obstacle is placed in path of light from distant source, a bright spot is seen at center of the shadow of the obstacle. Explain why. Very interesting question. Suppose you take a torch, though torch is not suitable thing because it is not extended source of light, but yet we can verify. So when the light is coming out from the torch, and then in its path, if you place a tiny disk, we expect that this part should be totally dark, but instead you will see that there is some light reaching at center of the shadow. Why does that happen? The reason is bending of light. So from the edge light gets bent, and hence some light reaches the central part, and thus diffraction is the answer. Next one. Two students are separated by 7-meter partition wall in a room 10-meter high. If both light and sound can bend around obstacle, how is it that students are unable to see each other uh, even though they can converse easily? Very simple. We know that bending of wave is directly proportional to lambda by d. Now here d is constant, so theta bending is directly proportional to lambda. Just find out lambda of audible sound and compare it with lambda of light. And you will realize that lambda of light, wavelength of light is so very less that bending will also be equally less, and hence the two cannot see each other, but the sound waves can bend enough so that they can listen to each other's voice. Next one. Ray optics is based on the assumption that light travels in a straight line. Diffraction effects observed when light propagates through small aperture slit around small obstacle disapprove this assumption. Yet the ray optics assumption is commonly used in understanding location and several other properties of image in optical instrument. What is the justification? Ray optics can be applied only when we consider the light to be traveling on straight line. Now, actually, we know that light does not travel because whenever it encounters some obstacle, it changes its direction. But then, when you consider the longer path and look at the diffraction pattern, many of the times the bending may be small. So, In such cases, ray optics is very much applicable. So to determine when the ray optics is applicable, we can use the Fresnel distance and check the validity of Z value in the given case. If Z is having appreciable value, we can apply ray optics. Otherwise, we'll have to go with wave optics. Thank you.